Alright, so we were focusing on routing protocols. Today we are going to see a protocol which is industry standard routing protocol. Open shortest path first. So this is not a protocol which is very poorly seen. It's well popular. It's highly recommended protocol. It's a very well-known protocol. This protocol you can see in most of the ISPs. There is also another protocol ISP prefers is ISIS. That is also same like Ospf. In what way they are same? This is what called as link state routing protocol. Link state routing protocol. Link state routing protocols or the protocol that discovers the path based on the link state advertisement. Link state advertisement. See, on the routers we have links, connections. Link state advertisements or the advertisement that is sent by every router. What do they send is, they send the status of the link. For example, when we have routers connected like this, router 1, router 2, router 3. When we have these routers connected like this, back to back, this link status will be advertised to R2. Now R2 will learn that I'm here, R3 is here, and there is a link connecting R3. Now this advertisement, router 2 will advertise to router 1. Now router 1 will learn I'm here, and when I'm connected to router 2, router 2 is connected to router 3, and there is a link, and that link is also connected to me. Router 1 will find that we are connected like this, and router 1 will send the LSA, link state advertisement. Now router 2 will learn that I'm connected to router 1, and router 1 is connected to router 3 also, and I'm connected to router 3. So this is how every router learns the topology. So when router 1 advertises the LSA, router 3 learns that I'm here, and router 1 is here, and router 1 is connected to router 2, and I'm also connected to router 2. So we have a triangle topology. So every router will be able to discover their topology. See, every router now knows the topology. When they know the topology, they know all the networks and where they are connected. Now, they themselves will decide on the best path. They no need to wait for someone to give the best route. All the routers, they themselves will decide the best path. They themselves can decide the best path because they got the topology. What is topology? The map. The map about the network. The map about the network and the routers to which they are connected. The design, like which router is connected to what are the routers and what are the networks on the interface and so on. So it is the link state advertisement that helps the router to discover this topology. This topology is also called as link state database. Now all the router has got link state database. Link state database. They've got link state database. Now this link state database on every router will be used by an algorithm called SPF. You see, the protocol name is Ospf, and this algorithm that Ospf uses is called as SPF, shortest path first algorithm. Shortest path first algorithm, SPF. Ospf is the routing protocol. SPF is just an algorithm. SPF, the shortest path first, is also called as binary tree algorithm. What is binary tree algorithm? Because you have not learned in college this topic, let me explain you once. You know, the SPF algorithm or the binary tree algorithm will choose the shortest path. For example, router 1, 2, 3, 4, 5, 6, 7. Let us assume the cost on the link, actually metric of OSPF is cost. The cost on this link is, assume 1. What SPF algorithm will do? Which path has got the shortest cost? Low cost path. For going to router 2, there are two paths. One, you can go like this. What is the cost? 1 plus 1, 2 links, 2. If you go via this path, it is 2. But if I go via this path, it's only 1. That is what called the shortest path. This is what binary tree algorithm does. It finds the shortest path. It finds the shortest path to reach destinations. Now, what is the shortest path to reach router 4? This way. You also have another way. This way. or this way, but they are all long distance. If you come via this path, it is 1 plus 1 plus 1, 3. If you come via this path, it is 1 plus 1, 2. But if you come via this path straight, it is 1 plus 1, 2 again, 2. So Ospf will use both this path and this path because they are having same cost. So what I'm coming to say is, once this topology is known with the cost, using bandwidth, Ospf will decide the cost. See, in this link state advertisement, even the bandwidth is advertised. Link status, when I say link status, it includes bandwidth, subnet on the link, status of the link, type of link, whether it is point-to-point or multi-point. So all the information about a link is advertised. We call it as link state advertisement, using which the topology with the cost to reach various destination is discovered. You see? So link state advertisement makes link state database. Link state database provides this type of topology information to the router, and this router now uses the SPF algorithm to see whether to go to RB network here 1.1.1.1, whether I should go, sorry, this is already in R3. R3 will see, say for example, I have 1.1.1.1 here. To go to 1.1. Okay, not here. 1.1.1. So router 3 also knows that there is 1.1.1.1 in the topology database. So router 3 says, okay, if I go via this way, it is cheaper than going via this way. So router 3's routing table now point towards this gateway to reach the destination 1111. Because the SPF algorithm is involved in finding the shortest route, this routing protocol is named as OSPF. Now, why is that O? What does that O stand for? Open. Open means what? Not closed. Open means what? It is not closed by anyone, meaning you can use any time you want. If you are willing to use this OSPF in your router, let's say you are the manufacturer of a router, Kiran routers, like Cisco router, you got Kiran router, made in India. That Kiran router needs a routing protocol. So Kiran router can use this OSPF, for which he no need to ask anyone permission, because this is an open standard protocol. It's an open standard protocol. Very well, you can use this protocol, install it in your Kiran router and sell the router. You can sell the router with this protocol. It's free for you. The protocol is free. For this piece of software that you want to put in your router before selling to the customer, you're not going to pay any money because it's open standard. Okay, next. This OSPF, because it is using link state advertisement to find the best path, it is called as link state routing protocol. So you should know now why it is called as link state routing protocol. OSPF is called as a link state routing protocol because it uses link state advertisements. Link state advertisements helps to form link state database. You can also call it as topology. This topology table link state database will be used by this SPF algorithm to find the shortest path. SPF algorithm is also called as binary tree algorithm that helps to find the shortest path to the destinations using the cost. SPF algorithm has got another name called Dijkstra's algorithm. Dijkstra's algorithm. Some people used to pronounce it as Dijkstra's algorithm. Dijkstra's algorithm.
Can you tell me the spelling of it?
I'll show you. The spelling is little bit weird. That's why people pronounce it as Dijkstra. The spelling is like Dijkstra. He uses this Dijkstra's algorithm. So in the year of 2000, he passed away. 6th August 2002, at the age of 72. He's from Netherlands. So SPF algorithm is an open standard. Even though Dijkstra proposed this algorithm, he did not take the ownership. SPF is an open standard algorithm. So this routing protocol OSPF is also open standard. Next, as I said, the metric, every protocol has a metric, right? OSPF metric is cost based on bandwidth. If bandwidth is more, cost will be less. For example, let's say I have two routers connected back to back. To reach this 2.2.2.2, no, I'm running OSPF on both the routers. I'm running OSPF on both the routers. Now this OSPF is seeing one interface with Ethernet, another interface with fast Ethernet. Do you know the speed of Ethernet and fast Ethernet? If yes, tell me.
No, sir.
Okay, I'll tell you. The speed of Ethernet is 10 meg. The speed of fast Ethernet is 100 meg. 10 meg and 100 meg.
Sir, what about gigabyte Ethernet?
That is 1000. Now, in this example, we are taking Ethernet and fast Ethernet. I told you more the bandwidth, less the cost.
Yes, sir.
So according to OSPF, the cost on this link is only 1. The cost on this link is 10 because more bandwidth, less cost. Less cost, that is the best path. So router 1 will see this as the best path to reach router 2 and the network behind router 2. If this link goes down, this will become the best.
Best part.
So based on the cost, the best path is elected, but cost is determined based on the bandwidth. 100 meg cost is 1, 10 meg cost is. So metric of OSPF, if someone asks, you should say cost. And you should say based on the bandwidth, the cost is calculated. This one, the cost can also be manually assigned. See, if you have a gig Ethernet, which is 1000 meg, you can give gig Ethernet cost as 1. For this, you can manually set cost as 10, and for this, you can manually set cost as 100. You can also manually set the cost. OSPF also dynamically decides the cost if you don't specify. Only if you don't specify more bandwidth, it will give low cost. When you do it manually, it won't consider the dynamic auto cost, automatic cost. Next, OSPF administrative distance is 110. What is the administrative distance of EIGRP?
90,
RIP?
120.
Very nice. OSPF is 110 and this is configurable. Every protocol, you can change it. So every routing protocol has got predefined administrative distance, but they are configurable. That's the good news. They are configurable. You can change it to 90 or 80 or 50, whichever you like. And you know the role of administrative distance. When you got multiple routing protocol, to prefer one routing protocol's path information, administrative distance is used. The routing protocol whose administrative distance is lower is what the preferred path. All right, next. This OSPF has got unlimited hop count support. Unlimited. You see, there is no limit. You understand now why OSPF is widely used? Because it can fit into any size network. Small, medium, big, any network. OSPF design, it's a hierarchical design. Due to that reason, it can support any number of hops. any number of hops. You see, if you have only one person in your office, there are 10 different type of duty. Only one officer in your office, he cannot handle it all of them. He will be like a RIP protocol, less hop count. If you buy a robot, even the robot, only one robot, it will be like one EIGRP, 100 hops. Instead of one, if you have many robots, that is OSPF. When we have many robots, we can divide the functions, the job, the load. Robot 1, clean my restroom. Robot 2, clean my bedroom. Robot 3, clean the living room. Robot 4, clean the kitchen. Robot 5, clean the car. Robot 6, clean all my table. So now any job comes, because I have more robots, I will share the load to all the robots. So even if I have a big house, maintenance is easy because I got more robots. I got one robot called Sony, another robot called Hitachi. When there was only Sony robot, maintenance took a lot of time. Now Hitachi robot helps a lot to share the load. Maintenance of a big building become easier when we have more robots. Like this. OSPF also has got many small areas forming one big autonomous system. See, in EAGRP, all routers are in only one autonomous system, one group. Whereas in OSPF, you form small areas, and all these areas are connected through one common backbone area, which is going to form one autonomous system. So because you got more areas, multiple areas, managing large network is easy. Have you seen, every state is creating more districts in India? Many districts. Every government, every 5 years when the government changes, they will include one or two districts, 3 districts, 4 districts in the state. Why? Managing is easy if you make small districts. Sometimes even the state is divided into two, no? Telangana and Andhra Pradesh. Earlier it was only one state, Andhra Pradesh, big state. So that managing, providing services became easier if you break down into small states. OSPF follows a hierarchy design that makes OSPF highly scalable routing protocol. For example, you have one area called area 1. You have many routers inside. You got another area called area 2. There also you got many routers. Many routers, many network devices, many servers, many computers, many laptops, cell phones. Like this, you have many areas. Area 10, area 100. In each area, theoretically, it is said you can have up to 255 networks. Then think about 100 areas, 100 into 255 networks. Now, to connect all these areas, one big office, one big autonomous system, we have one backbone area. This backbone area should be connected by all the areas so that the inter-area communication will be possible. So you will have one router which is a border for this backbone. This router is also connected to area 2 and area backbone. Area 0 is what called as backbone area. So this router, if you see, is connecting to area 0 as well as area 10. This router is connecting. So this brown one is the backbone area. And the router that are connecting to both backbone router and non-backbone backbone area and non-backbone area are called as ABR router, area border router. So because you got this area concept, we can have any number of networks in our autonomous system. If you see this picture here, you got one backbone area to which all other areas are connected. This is how it should be. You see? And this is what I told ABR, area border router, because it is having one interface in area 0, another interface in area 1. Without area backbone 0, area 1 cannot communicate to area 2 or 3. Even if you have a direct connection, they won't advertise anything. Advertisement is only through area 0 it has to come. That is how Ospf is designed. Inter-area communication is only possible through a backbone. Fine. Next. Now we understood that there is something called area in OSPF, no? So to tell which area this network belongs to, when we configure, we will give area ID. Area ID is to tell OSPF about a link to which area that link belongs to. I showed you that between two areas, area 0 and area 1, there is a router. Now, let's say here 10 network, here 20 network. We need to tell OSPF on this router to which area the 20 belong to. That is area 0. So this link belong to area 20. When I say 10 network belong to area 1, then the OSPF on this router 1 knows that the link which has got 10 is a member of area 1. So area ID is important. Next is the process ID. Process ID is to identify the OSPF process. Simple. You need to say router, like you used to configure EIGRP. Here we say router OSPF 10. What is this 10 means? Process ID. It is not autonomous system number. In EIGRP, it was called as autonomous system number. It is in OSPF, it is process ID. To identify this OSPF process running on the router, you need this process ID. You can have more than one OSPF on the same router because you can differentiate one OSPF from the other using the process ID. I can run OSPF 10, OSPF 9. Thirdly, we have another ID called router ID. This is the ID given to every router, and this ID should be unique to every router. No two routers can have same router ID. So in a classroom, if you have two people with the name Kiran, it will be confusing. Everyone should have different name in class. Only then there won't be confusion. See, when advertisement is going, they go with the name. If two routers have got same name, then there will be confusion. Router ID is a unique name given to each router so that they can be uniquely identified. Router ID is to uniquely identify the router and the update given by the router. It's router ID. Now, how this router ID is given? You can manually give. Router ID will be in this format, 32-bit format, 8-bit, dot 8-bit, dot 8-bit, dot 8, same like IPv4 address. So you can go to a router and configure 1.1.1.1 as a router ID. The command is simple, router ID under OSPF. Router OSPF 10, router ID 11111. So you can configure this on this router. On another router, you can say 22222. So if you don't manually configure, it will automatically pick the IP address from the logical interface called loopback interface. So you can create a logical interface called loopback. So from there it will take. If you don't give manually IP address, it will take from the logical interface address. If you don't have logical interface and when you don't manually configure, it will take the highest IP address from the physical interface. Highest IP address. Don't forget highest IP address. For example, if I have fast Ethernet with 192.168.1.1, another interface fast Ethernet 0/1 with 11.0.0.1, this will be taken as the ID for this router automatically. So if you give manually, it won't take automatically. Only when you don't give manually, it takes the router ID automatically. First preference is given to the loopback interface. If you don't have loopback interface, physical interface. So every router needs a unique name in Ospf so that when they advertise, they will put the name and sender. That will prevent loop. If two routers have got same name, same router ID, then problem. That will conflict. We have seen three IDs: router ID, area ID, process ID. Area ID is to identify to which area the link belongs to. Process ID is to identify the OSP of process. And router ID is to uniquely identify the router. Yeah. So in